Hello children, welcome to Samveda e-learning program. Today we are discussing about a topic electricity in class 10th and we are discussing the subunit 2, that is the second session of the 5 sessions of the topic electricity, and the subunit is Ohm's law. As you know that this topic electricity has been divided into 5 sessions. As you can see, basic concepts in electricity, this we already learnt in our previous class. Today's class we are learning the second subunit, that is the Ohm's law. Next we will be learning factors on which the resistance of a conductor depends, resistors in series and parallel, and heating effect of electric current. Children, in this subunit Ohm's law, what we are going to learn here is the experiment on Ohm's law and potential difference and the electric current graph, meaning of electric resistance and its unit, solving numerical problems based on Ohm's law.
In olden days, when there was nothing known about electricity, people were amazed by one thing. They used to observe that the tree gums or tree resins, when they were taken near to hairs, they were not attracted at all, no matter how many times they tried. As soon as the tree resins or tree gums were rubbed against the fur and then brought near the same hair, then they would attract each other. Not just this, people were also wondering about another important phenomena. That is lightning. People were wondering what is the reason for this sudden flow of power, and the person who gave the answer to this is Benjamin Franklin. He introduced the concept of electricity to the world. Electricity is produced by making water flow down the turbine and rotating the turbine, because of which by electromagnetic induction the electric current is produced in various types of power generating stations like solar, wind and thermal power stations. And from the power stations the electric current is supplied through transformers to our homes, and in homes we use the electricity for various type of electrical appliances. And in today's world there is no home that is not connected to electricity.
Children, as you already know that we use electric current in our homes and industries and various other places. And these electrical appliances are very familiar to you. Fan, yes. What is this? An electric kettle, you are right. And this is very familiar thing to you, that is a mobile charger. All these things, they utilize this application of Ohm's law. So as you can see, this Ohm's law is not very far distant to us. It is in our daily life. We use it through these appliances. So we shall try to understand what is Ohm's law in today's class. Children, as you already know that for any object to move, there has to be some work to be done. In the same way, here as you can see, an electric circuit is shown here, and what is the source of the electric current? It is a cell, right? And the cell is connected to the bulb, and the bulb is connected to what is that? What is that component there? It is an electric switch. So this completes the circuit. Here, in order to the electric current to flow through the circuit, we have that electric cell, which provides the potential difference needed for the flow of electrons. Already the electrons are present in the wire, but those free electrons present in the wire, they won't move in a one particular specific direction. The reason is there has to be some work done. So, that cell is doing that work by bringing the potential difference, that is the difference in pressure of charges at its ends. So, for flow of charges in a metallic wire, the electrons move only if there is a difference in electric pressure. This electric current we already learnt in our previous class, that it is the amount of charges flowing through a cross sectional area in unit time. So, the total amount of charges Q and the in unit time T, that ratio is what we call as electric current. More the charges, more the current in a specific unit time. Now, in order to understand, come let us see this activity and continue the lesson further.
Children, this is an activity to see how the ammeter, as you can see, and the other electrical components, resistor, electric bulb and a switch and a cell, how are these connected? As you can see, the ammeter is connected in series with the electric cell. That means it is connected one after the other. The positive terminal of the battery is connected with the positive terminal of the ammeter, and you can see the potential difference is 50 volt at the cell, and here as we can see the switch is open, now it is closed. As soon as it is closed, you are observing that the bulb is lit up, and also the charges inside the wire are moving very slowly. Now, when the switch is open, the bulb is turned off. So, what is this equipment here? Voltage. That means it is a voltmeter. It is used to measure the potential difference across the ends of a conductor. So, now we shall measure the potential difference at the ends here at the electric bulb as well as the resistor. So, now I am connecting the voltmeter at the ends of the electric bulb. Now, children, this connection is what we call a parallel connection. That means the electric current is flowing in two branches. One is in the electric bulb, and in the other way is also moving through the potential through the voltmeter. So, you can see the value 45.45 volts, but we gave the potential difference as 50 volt. So, the other 4.55 volt is found at the ends of the resistor. So, totally when we take the values, we will get the total value is equal to the potential difference at the cell, which is 50 volt. You can verify it here. See, now if we measure the total potential difference at the ends of the two conductors, it is equal to the potential difference at the cell. So, we have learned through this experiment what is series connection and what is a parallel connection for ammeter and voltmeter.
Children, you just saw this activity. Here we saw how the ammeter was connected in the circuit, in what manner. Now, I think you should be able to answer this question. Here is the ammeter and this is the battery, and these two are the resistances. These are the symbols of electric components that we learnt in our previous class, which are used in this circuit diagram. Now, what is the answer for this? Yes, it is the ammeter is always connected in series. Children, here is the next question. In this diagram, how is the voltmeter connected in the circuit? Yes, You are right. It is connected in parallel because we measure the potential difference at the ends, at the two ends where we want to measure the difference of charges, right? So that is why we connect it in a parallel connection. Here you can see which is the right and the wrong way to connect the ammeter. This is the wrong way of connecting the ammeter to the battery, as it is connected across the battery rather than in series with the battery, which is the proper way. So are you able to make out which is the right and wrong way and the reason behind it? Now children, we have seen the two concepts, that potential difference and electric current. Now are these two depending on each other? That means whenever there is a potential difference supplied to a conductor, is the current depending on the potential difference? What do you think? Come, let us see through this experiment called as Ohm's law experiment.
Materials required: battery eliminator, ammeter, voltmeter, a resistance wire, rheostat which is used to vary the resistance, a switch or plug key, scale, connecting wires. The procedure for the Ohm's law experiment: the components should be arranged as shown in the circuit diagram. The voltmeter is connected across the resistance wire, and again series connection with the ammeter. As you can see, the eliminator is connected to the voltmeter, and from the voltmeter we are connecting it to the ammeter. So this is the connection we have made. Now from the ammeter through the plug key we will connect the rheostat, and from the rheostat to the negative terminal of the battery. Now as you can see, the rheostat is connected to the negative terminal of the battery. Now the resistance wire is connected in parallel with the voltmeter. Now as we switch on the plug key and move the rheostat, then we are observing that by varying the potential difference, the current is also varying. Now by measuring the electric current for different potential differences, we observe that the values are proportionally increasing. So we note down the values for 0.1 volt, 0.2 volt and 0.3 volt. As you can see, the values are increasing proportionally, which we noted down in a table like this. So the ratio of V by I is constant 0.5 ohms for this wire, so which is the resistance of the wire, that is potential difference divided by electric current. This constant is called the resistance of this wire. Now we will take out the wire and we will measure the length of the wire. Now the values of electric current on x-axis and the values of potential difference on y-axis are plotted on a graph, and we observe that the graph is a straight line. This slope of this straight line is the resistance of this conductor, that is resistance is equal to V by I, that means AB by OB. By calculating this value and dividing by the length of the wire, we get the resistance per centimeter of the wire. Ohm's law is used to design the circuit diagrams of various appliances. It is also applied to find out the amount of electric current at a specific potential difference in a conductor. Children, we just saw through the Ohm's law experiment the values of potential difference and electric current, and we have also noted it down. So now we shall plot the graph by plotting electric current and potential difference. As you know that initially we got 2 amperes for 1 volt of potential difference. As you can see, we have plotted it for 2 amperes. For 1 volt we have got 2 amperes of electric current. So now again the next value what we got was 4 amperes of electric current for 2 volt of potential difference. So we will plot that value, which is 4 amperes for 2 volt of potential difference. As you can see, we have plotted it 4 ampere for 2 volts of potential difference. Y-axis is potential difference and x-axis is electric current. Now, what is the third value that we calculated the electric current for? Yes, it was 6 amperes of electric current for 3 volts of potential difference. So we have plotted it. Now we see that we have got 3 points here. As you can see, 6 amperes for 3 volt of potential difference. Now we shall connect a line between 3 and we shall see that it is a straight line. That means for a conductor we are observing that these values fall in a straight line. This ratio falls in a straight line. That is, the ratio of potential difference and electric current is always constant. That is why we get a straight line here. So by taking the slope of this line we get the resistance.
Children, you just saw the Ohm's law experiment. What is the result we got there? Yes, whenever we provided the potential difference, then we were getting the electric current, and what we observed was the plotting of these two values on a graph sheet of paper resulted in a straight line. So potential difference we have taken along y axis, and when we provide this potential difference there was electric current in the electric circuit. We measured it, and when we plotted it we got a straight line, right? And as you can see in the experiment that the V by I ratio we got was 0.5. So we can say that whenever the potential difference and electric current are plotted for a conductor, we will be getting a straight line. Now what is the reason for this? Yes, as you saw that V by I value was a constant in the experiment. It was equal to 0.5. So here we can take the ratio of the y axis V and the x axis A, that is amperes electric current, and we will get the constant. So what does the Ohm's law state? Here is the physicist George Simon Ohm. He stated that electric current flowing through a metallic wire is directly proportional to the potential difference V across its ends, provided the temperature remains same. To understand it better, come let us see the mathematical representation of this Ohm's law. Here V is directly proportional to I. This is the proportionality symbol. V is directly proportional to I, and the V by I is transposed to the other side, then it is a constant, and that constant George Simon Ohm called it as resistance. So by cross multiplying we are getting V is equal to I into R. So this equation V is equal to I into R is the equation of Ohm's law. In order to understand this Ohm's law and the mathematical representation further, come let us have a look at this activity.
Children, here we shall verify the Ohm's law through this experiment. The value of electric current you are seeing 9 ampere. Now what is happening when I increase the resistance? Yes, the electric current is decreasing 6.3 milliampere because the resistance increased. So now what I will do is I will start with the same values, that is 4.5 volt, the potential difference, the value of electric current is 9 milliampere. Now I will increase the potential difference. What will happen to the electric current? Yes, it is increasing. As you can see, the potential difference increases, so the electric current also increases.
Children, you just saw that activity. What was happening in it? Whenever we were increasing the potential difference, then the electric current was also increasing. It was directly proportional. But whenever we were increasing the resistance, electric current was decreasing. That means electric current is inversely proportional to resistance and directly proportional to potential difference, because electric current decreases when we increase the resistance. So what is electric resistance? Now let me give you an example. If you take an electric bulb, that electric bulb needs some potential difference to function. But when the potential difference or the voltage that is given to the bulb is too high, what will happen to the bulb? Yes, you are right. The bulb will burn because of the high voltage. Now, we don't want that to happen to our electrical appliances. Hence, we need to control the electric current that is entering the circuit or entering the conductor. That controlling is done by the property called as electric resistance. It is the property of the conductor to resist the flow of charges in it. What is meant by this? Here, as you can see, when the charges are moving through the conductor, then the neighboring atoms, they apply a force of attraction on the moving electrons and avoid the free flow of electrons. Also, these electrons, while flowing, they collide with the neighboring atoms, resulting in a production of heat. That means whenever these charges or electrons are moving, more the number of attractions and collisions, more the amount of heat is produced. So what do you think? Do we need such obstruction? Yes, you are right. We need such obstruction because we want to control our devices. Otherwise, all of the devices, they get burnt out. Now, to measure resistance, there is a unit called as ohm, which is a Greek letter called omega. As you can see, this is the symbol of ohm. Now, when do we say the electric resistance is 1 ohm? Yes, as you can see, the mathematical equation of Ohm's law says V is equal to I into R. So, we have transposed I onto the left hand side, V by I is equal to R. So, now if the potential difference value is 1 volt and the electric current value is 1 ampere. So, by providing the potential difference of 1 volt, if the electric current flowing in the conductor is 1 ampere, then we call the resistance as equal to 1 ohm. Now, we have learned the mathematical equation of Ohm's law. Now, let us solve a numerical problem on Ohm's law. The potential difference between terminals of an electrical heater is 60 volt. When it draws a current of 4 ampere from the source, what current will the heater draw if the potential difference is increased to 120 volt? You better note down what is the value of V and what is the value of I. Yes, you are right. Value of V is 60 volt and value of I is current is 4 ampere. So, what is the resistance? Can you calculate? Yes, you are right. According to Ohm's law, R is equal to V by I and value of V is 60, value of I is 4. So, we get the value of resistance as 15 ohm. Now, what has the problem informed us? The potential difference has been increased to 120 volt. So, we need to calculate the current that the heater draws. So, to calculate the current, I is equal to V by R. V, the potential difference, is 120 volt and resistance is 15 ohm. So, we get electric current as 8 ampere. Children, now you need to answer this question. The property that resists the flow of electrons in a conductor is, yes, it is resistance. It is a property that every conductor, no matter how much good conductor it is, it has some sort of electrical resistance. Some conductors have less electrical resistance and some conductors have more electrical resistance. So, what do you think? In heating appliances like electrical iron box or electrical kettle which you saw in the beginning, whether the electrical resistance is less or more? Yes, you are right, the electrical resistance in heating appliances is more, because we choose such conductors where the electrical resistance is more and we get more amount of heat out of the electrical appliances because of the collision of electrons with the atoms. Children, in today's class we have learned about the Ohm's law. Now you need to solve these questions. Please write down how much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm. What is the function of rheostat in an electric circuit? Have you noted down, children? Yes, try to solve these questions and more number of questions in the exercise based on Ohm's law. So, today we have learned the statement of Ohm's law and the potential difference and electric current graph, which is a straight line, and the meaning of electrical resistance of a conductor and its unit. Thank you for watching this, children. Hope you keep on learning the topic electricity, and we shall continue it in the next sessions. Thank you.